Okay, so now that we've talked about what a stream is, we talked about common aggregate operations, we talked about splittable iterators, we're now going to talk a little bit more about terminating a stream. And I'd gone through this a little bit earlier, but I want to kind of go through it a little slower and talk about this. And it's important for you to know some of the things we're about to talk about because you'll have to implement some of this stuff for the next assignment. So we're going to terminate the stream. And I'll also show you how to implement collectors, which you'll have to do. So what does it mean to terminate a stream? Well, every stream finishes with a terminal operation that yields a non-stream result. That's the last thing that goes on here. And as we mentioned before, there's a couple of different types of results. There's no results or no values, right? So for each is a good example of a termination operation that doesn't actually return any value at all. Now, in this particular case, it may have a side effect, right? It may print something to the display, but it's not returning a value to the stream. You can also return a collection. So as we've been discussing multiple times now, we might have something that collects the results into a list. So that's a reduction operation that takes the stream and turns it back into a list. I think I mentioned before you can use this with a bunch of collectors, right? We've got things like grouping by that puts stuff into categories, which is kind of cool. And you can also see here that you can do various operations to collect that will change the type of output we're going to have as a result. For example, you'll see that I'm using tree map here. So I'm creating a map that's a tree map. And one of the things a tree map does, unlike, say, a hash map, is a tree map will get rid of duplicates because it stores it as a ordered binary tree. So tree map will take anything that's a duplicate and just throw out everything except one of the elements. And so that's what tree map does. If we put a hash map, then we would end up allowing duplicates. So you can see that collect can also transform the results a bit as it puts it into its final output format. And you can also return a primitive value. So I think I showed this before, reduce. So reduce is a way of being able to have reduction operations that manipulate the stream that it gets up to that point and then folds them all back together again into a single result. So here we're going to start with a value of 0, and then we're going to go ahead and add every two elements together, yielding a single result, and that gets done on the entire tree of results until we have a single result at the end. You could also use the .sum operation to do this if you didn't want to have reduce. .sum is just a fancy way of doing that to compute a sum. And there's a 3-parameter version here that's used in parallel streams. And in parallel streams, if you have a parallel stream, in other words, if it says .parallel stream, not stream, then this computation is done as we are doing the processing in each thread sequentially, right? We break the input up into chunks, and then each of those chunks will run in parallel. And that's the operation that's done within a chunk. And then this is the operation that's done to map all the chunks back together to get a final result, to do the reduce operation, to do the combine. They turn out to be the same thing in this case, but in general, they don't have to be the same thing. All right, so that's just a quick summary of what you can do to terminate streams and a couple different kinds of things you can do. Now, if you end up doing a collect operation at the end, then it's possible to implement a collector. Now, you'll get collectors out of the box. Java gives you a bunch of collectors, but you can also define your own. So in either case, either you use the ones that come out of the box or you define your own. What's happening under the hood is there's an interface called collector, and it's used to accumulate the input elements into an internal mutable result container that will be the result of the collect, right? So when you say .collect, the collector is what's doing the accumulation and producing the final result. So let's take a look at this and see what it does. So there are 3 generic types that are passed to the collector interface. And there's a really nice article here that I recommend you take a look at that explains how to do all the collector stuff and shows a bunch of examples. We'll show some examples too. The 3 types are as follows. There's type T, which is the type of the objects that are being collected. So it might be int, or it might be, sorry, integer, it might be long. So it's got to be some reference type. It cannot be a primitive type. It can't be like, int. It needs to be integer with a capital I. The second type is the accumulator, which is the object that we're using to collect each of these elements. So it might be an array list, for example, of type T that we're collecting into. For your program, for the next assignment, it's going to be array, right, because you have an array class. And then type R is the final result. So that's going to be the result that's returned when we're all done accumulating all the elements into something. Now, in this, it's often the case that the accumulator and the result are the same, but they don't have to be, and we'll talk about that later too. There are 5 methods defined in the collector interface. There's supplier, and that's a factory method that returns an instance that's used to create the empty accumulator. So you might say return array list : new. That's a constructor reference. We have accumulator. That returns a function that adds a new element of type T to the accumulator that's hidden by the collector framework. So that could be just giving back array list add, because that'll add the next element, or array add in your case. There's the combiner, and that's what's used when you need to merge things together. And you can see here, this is going to take 2 lists and add one of them to the other, and then return the merged lists. It's kind of like merge. Might have been a better name, merge. There's something called finisher, which returns the final result, which could be the same as the result that's left over when the combiner does its final thing. So if that's the case, you just return the identity function, just says return the internal collector, or return the internal accumulator, which could sort of be a no-op. And then the final thing is this method called characteristics, which tells the framework. Remember, Java's managing this framework for you on behalf of this interface you fill in. It tells you certain things about the properties of the collector you're making. So does order matter, or does order not matter? If order doesn't matter, it can make things a little faster. Is it an identity finish, which means is the result of this thing just whatever was left over at the very end, or is something else happening? Can it run concurrently? Can you actually have this called from multiple threads? Is it thread safe? So you have to decide which of these flags to set in order to be able to tell the framework what to do. So, surprise, surprise, there's a whole pile of common collectors for common types like array lists and vectors and all kinds of stuff. And that just kind of comes out of the box for free. So if you take a look at the toList implementation in the Java collectors class, you'll see that here's what toList does. It uses this thing called a CollectorImpl. This is a CollectorImpl. This is internal to Java that implements the collector interface and is nested under the collectors class. And what it basically does is the CollectorImpl simply just takes all these different types and stashes them away into an object that can be used here. So it's going to say array list new, list add, has a little lambda expression to merge 2 lists together, and then it basically says that this is going to be the identity finisher. So that's just what happens under the hood. I'm just showing you what Java does internally to implement this stuff. You can also implement your own collector, and there's a couple different ways to do it. One way is to do something kind of like what they do. Another way to do it is simply to use a factory method in the collector interface, Collector.of, where, as you can see, you can specify 4 things. You can specify the supplier, you can specify the accumulator, you can specify the combiner, and you can also specify the finisher. And so these are things that you can just provide, or you can make your own class to do these one at a time. And this is what I actually use in my example to get these nice, pretty results that are merged together. And we're almost done. If you want more information about how to implement a collector, which can be handy for the next assignment, I recommend you take a look at this video. It's a really, really nice tutorial by a colleague of mine, Angelica Langer, who talks about how to implement collectors. her collectors are way more complicated than you need, but she explains what a collector is and how the interface works and the different means to implement that stuff. OK, so that is the end.